everyone. This is Prashant Shukla from Q-Infotech, anchoring today's webinar and supporting the event logistics. On behalf of Q-Infotech, I would like to thank and welcome you all to this web event on automated layout testing for responsive web designs. The agenda for today's webinar is to discuss the challenges of UI automation on various devices. According to ITU, International Telecommunications Union, United Nations, the mobile internet penetration is touted to be more than 60% in US and more than 50% globally. The number of devices that are available for our web applications and the form factors available with them had made UI automation in particular and testing in general a very tedious task. The effort involved has increased multiple folds related to every new device that's in the market. Our webinar today showcases one of the initiatives that we have taken here at Q-Infotech to efficiently create UI automated tests and evolutionary creation of test suites for UI automated testing of the responsive web applications. Please join Ramandeep, our head of test automation group, as he discusses the challenges and demonstrates the solution that we are working on. Please feel free to send your questions to us at any time during the web event using questions tab on GoToWebinar platform. At the end of this session, we will try to answer all the questions received during this web event. All participants are on mute at this time to allow for the speaker to present. Over to Ramandeep.
Thank you, Prashant. Hello, everyone, and a very warm welcome to this webinar presentation by Q-Infotech. At Q-Infotech, our test automation group is focused to doing continuous research and development in order to make our automated test solutions more effective to cater the present-day test automation needs as well as any future need. And in order to showcase such research and development that we have been doing, we have done a lot of webinars in the past. This webinar is in line with the similar series of webinars. And today, we're going to talk about automation of layout testing of web applications, as well as testing responsive web application designs. Let's have a quick look at the agenda before we proceed with the webinar. First, I will talk about the problem statement through a small story by example. Then, we will talk about the need of layout testing and why it is necessary to automate layout testing. Then, we would look at the tools that are available in the market using which we can do automated layout testing. Followed by that, we would look at the challenges that are there in automating layout testing and also the challenges that are there in the existing tools in the market. Then, I would showcase our framework, the solution that we have developed using which we can do both functional testing as well as testing of layout of applications and responsive web design. Then I will talk about the various detailed features of our solution, the framework, and I would end by talking about a brief summary of this discussion and the next steps where we want to take this framework further. Throughout this presentation, I would showcase a number of demos. And like Prashant said, you can fire your questions through the questions tab, and we would take all the questions at the end of the presentation. Let's try and understand the problem statement from a story. Consider a modern day web application. Like any web application that we are dealing with nowadays, this web application also needs to support all the different browsers that are out there. All the different users are trying to access the web applications with a different browser and a different version of the browser. On top of that, we now have devices, and there's a rush of end users who are trying to access the web application with their own specific device. And each of these devices comes with a different form factor, and every device comes with multiple orientations, which adds up more permutation and combination of form factors, resolutions, and browsers, and overall weight to on top of the tests that we have to do in order to make sure the web application is consistent across all these compatible environments. Consider that this is the web application I'm talking about. It's a basic application with a header, a footer, content on a main pane, and then you have a sidebar with a bunch of links like the welcome message, a sign-in link, register, and a bunch of links. Like any web application, this would have standard functionality like sign in, register, and a bunch of other functionalities. Now, in order to test this web application, we created an automated suite so that the regression test needs of this application can be catered. Let me execute that automated test suite and see what happens. Now, in order to run this test suite, I need to fire a command, which is rake run spec. Now, the automated tests that we have created for this application are written in Ruby. Like any web browser-based test, we have used Selenium to automate these tests, and we have used Ruby as our scripting language. Rake, as you know, is a build automation tool very similar to Maven or Ant in Java. Now, when I run this command, it would fire the test and the browser would launch. Let's see what happens when I run this. So you would see that the browser has just launched. It has launched the targeted web application, and it would perform all the necessary actions like verifying the home page, going into the sign-in link, performing the sign-in, and making sure that a welcome page is displayed. These are all the tests that are listed on the console that were performed. On home page, we verified the correct title, we verified the welcome message on the sidebar, presence of the sign-in link, the registration link, then we clicked on the sign-in link, and then we entered proper credentials in the login form, and then we made sure that on submitting the login form, we get a welcome page. So the automation is performing this test execution properly, and it is giving us a proper result that 7 tests were executed and none of them are failed. So all the tests are successful, which is good. Our automation is working perfectly. But if you look at this application closely, you would find that there is a problem in this application. And what is that problem? Well, consider a user who's trying to access this application from a device which has a smaller form factor. For instance, a tablet or a phone. Now, right now, I have opened this application on a desktop with the maximum resolution available on this desktop. But for a user who is coming in from a tablet, he would see this application something like this. Do you see the problem now? The sidebar is actually wrapped behind the main content of the application. And that makes it really unusable for a user who's coming in from a smaller form factor like a tablet. But what happens when I try to execute the same automated test suite in the smaller form factor? Let us see what happens. Now, in order to do that, I would have to make a certain change in my configuration of the test to change the test resolution. So this is the configuration of my test suite, and I have a parameter called form factor, which was earlier attributed as desktop full. Now I'm going to change this to tablet, so that when the test is executed, the resolution is changed to a tablet form factor. Let us see what happens when I run the test now. You will see that the browser would launch, it is resized to a smaller tablet form factor, and the test is executed. And once the test is executed, you would see that we have the results in front of us, and even this time, the results were successful. There were no failures in the results. But if you try to execute the same test manually, you would be able to clearly point out the problem, which is that the sidebar, the whole of the sidebar and all the available links are wrapped behind the main content, and you cannot actually perform these tests manually. But since Selenium is the tool that is being used to automate these tests, and it does not essentially test for your layout issues and the UI rendering issues, it did not fail these tests. So what did we learn from this example story? When we want to provide automation coverage using Selenium tests, when we talk about functional tests, behaviors, and workflows, These kind of tests can be easily executed and created through our Selenium-based test automation. And our test suites can provide appropriate coverage to all such kinds of tests, which are functional tests, testing the behavior and the workflow in the application. But what are the things that are missed out when we do functional test automation only? We miss out on testing for look and feel issues, layout issues in the application, the issues in which the elements are misaligned in the application. All such issues, when a manual person is trying to test the application, he would be able to clearly make out because he's testing the application visually. Whereas if an automated tool is testing the application, he would not be able to make out such issues in the application. That is exactly what we call as layout testing. Testing not just for functionality, but also for look and feel, layout, and misalignment in the application when it is rendered under various different resolutions, form factors, and on different devices. So where does this need of layout testing actually came from? Well, obviously from the various different set of browsers that an application has to support. There are various different browsers out there and different versions of the browsers, and the developers need to make sure that the application functionality and the behavior, and along with the behavior, the UI of the application, the rendering of the application remains consistent across all these browsers. And then on top of that, now the developers also need to make sure that their UI is consistent across not just all the browsers on the desktop machines, but also on different devices and different form factors on these devices. And each of the devices, each of the handheld devices essentially nowadays has at least 2 different form factors. For instance, your iPhone. If you hold the iPhone in the portrait mode, you would have a different resolution available to the application, whereas when you change the orientation of the iPhone to landscape view, you now have a totally different width and height available for the application to render. And then on top of that, nowadays developers have a totally different way of creating the UI of the application, something we call as responsive web design. And what is this responsive web design? Well, the application nowadays, which are so-called as responsive web design enabled, the UI of those applications automatically arranges its components to fit and display properly inside whatever resolution is available inside the browser in which the application is open. That means if you resize the browser at runtime, the application UI would automatically change, expand, or remove the components so that the display is proper and all the functionality and the UI is available and displayed properly inside the available resolution. And in order to do that, the developer has a lot of support from the development community. There are frameworks like Zone Foundation. There are frameworks like Bootstrapper, which are some of the very popular open source frameworks using which we can build responsive web design. Then you have tools like Adobe Edge's Reflow, which enables building application UI which is responsive in nature. So what are the existing solutions using which we can automate some of this layout testing? There's an application, a web application available out there, which is called as Browsera. Now, what this web application does is it takes a static URL of a static page, then it takes a bunch of browsers as parameters, and when you mark one of the browsers as your benchmark, this application would return a series of images which highlights all the differences that are there in the remaining browsers compared to the benchmark browser that you have marked. So with image comparison, Browsera is able to identify the layout issues, the layout differences between all the different browsers that you select. Then there are libraries like Phantom CSS and Rate. These libraries are programmable APIs which can be consumed by any application programming language. And then these libraries again use image-based UI comparison to identify layout issues, to identify layout differences in the web applications. Then we have a little more mature framework available in the market, which is called as Galen framework. This framework relies on specification versus image comparison. You need to provide the specs of a page, and Galen framework essentially compares those spec of the page against the actual rendered page and figures out if there are any CSS and layout differences and issues in the page or not. But what are the challenges with existing tools and solutions? Well, first and foremost, all of these tools work only on static URLs and static pages. That means if you have an application such that all the different pages and sections of that application can be accessed through static URLs, you can use any of these tools to test your application properly. But like pick any modern day application, pick any application that you work on nowadays, you would find that the application essentially is not static anymore. They are dynamic and they are driven through user experience. That means you might just have a single URL to access the landing page of the application, but beyond that, whatever is displayed on the UI on the same page of the application is driven by what user workflow you are performing, what user action you're performing inside the application. That means whatever UI is displayed is driven by the workflow that is performed by the user. And hence, these are dynamic applications. They are not static pages. The application pages keeps on changing with different user action that you perform on the page. And they don't certainly have specific URLs for each of the sections of such dynamic web applications. And hence, you cannot actually test such applications using any of these tools properly. And on top of that, most of these tools, except Galen, they use image comparison to highlight the layout issues between different browsers or between the same application. But there's a problem with image comparison. With image comparison, you can certainly point out the differences, but it is really difficult to analyze whether that difference is actually a problem or a layout issue in the application. Sometimes one of the elements may be a little off compared to its earlier position in the screen, but it may not always be a bug, a layout problem. So we need more than just image comparison to be able to properly identify a layout issue in the application. So how did we solve this problem in our framework? Well, what we did is we took some of our existing frameworks and we integrated some of these layout testing tools alongside functional test tools in our framework. So with the same framework, now we have the capability to do functional testing as well as to do layout testing side by side. And the problem of testing only static web pages with a static URL is solved because the workflow now in the test is governed by your functional test steps, and the layout test is governed by the layout test tool inside the functional test spec. So a merge of these two tools, merge of multiple such tools gave us this framework in which we are able to do layout testing side by side with functional tests. And on top of that, we're also able to do testing of responsive web design. We're able to resize the application at various spots and make sure that the UI is responsive at all those different spots inside the application, even after performing certain workflow, a user experience workflow in the application for dynamic applications. Let us have a look at a demo of this framework and see how this actually looks in action. I'm going to execute the same test, but this time with the layout check in place. So when I say rake run specs layout, it is going to run the same test, but with the layout check in place. Let me run this test and see what happens this time. You would see that the browser has executed and it would perform the necessary test, which is to go into the home page, go into the login page, execute the enter valid credentials, go into the welcome page and make sure that welcome page is displayed. But this time, the test actually failed. It did report a failure. And what was the failure? It failed at exactly the place where I have introduced the layout test, which is that the display of the page should be in proper layout. And what is the exact failure? One of the elements, in this case it's the greeting element, is not available at the exact position that we expected inside the application. Let me show you the test script for this test as well. Here is the RSpec test for this test. You can see that it's standard RSpec test with standard page object driven DSL made for this application. So you would see functions like driver.title, homepage.greeting, homepage.signin, homepage.register, and functions like and in addition to all the standard tests, in this particular test case, I've added an additional test case, which is check for layout of the application. Now, this test essentially performs the layout check at that particular spot in the workflow. So the workflow is driven by all the other steps, and the layout check is driven by this particular method call inside my application. But how does my test know that what does the layout test should expect inside the page when it is trying to test the layout of a page? Well, in order to provide the expected results to the page, we have a neat mechanism in which we provided a spec file which contains a CSS style annotation, CSS style description of what are the objects and what are the properties available for each of those objects when the page is rendered properly in the application. That serves as our expected result in case of layout tests, and we create that spec file in a very similar format that is shown on the screen. For instance, suppose there is an object called menu, there's an element called menu on the screen, and we need to make sure that that element at one particular spot in the application is visible. So we would say menu is visible, and if I want to make sure that it is aligned extreme left of the screen vertically, then I would say align vertically to the left of the screen. Once I've created this spec file, let me show you the spec file for the last test that I executed. This is the spec file. So you would see that this is the test that actually failed, the spec for greeting that failed. So this is a spec file that we created for home page, and then we passed the reference of the spec file into the check layout function. Now let us have a look at the features of this framework in a bit more detail. Now, besides providing certain attributes of the object, the element that we want to test on the screen, we can also provide proper values of these attributes. For instance, if I want to test that the home page menu item home button should be exactly about 40 pixels in width. So I can give that as one of the attributes, that width colon 40 pixels. If I can also give expressions in place of exact attributes. For instance, height should be greater than 50 pixels, or height should be between the range of 50 to 100 pixels. So we can give exact values to each of these attributes, these CSS attributes, or we can give ranges in form of expressions. Besides testing for the attributes of these elements, we can also test for things like the position of the element, the proximity of the element with respect to the complete screen, or some of the other elements inside the application. For instance, menu item home button. We can test that the menu item home button is near another element, which is menu item profile button, and it is to the left of that element with a difference of 10 pixels. Or we can say that menu item home button is below the header with a range of 10 to 30 pixels. Or we can also say that menu item home button is inside another element called as menu container. And we can say this other way around as well, that menu container contains menu item home button. So with all these fluent CSS style syntax, we can describe how our UI should look like. And then when we are performing the spec checks, when we are performing the layout test, these specs are compared against the exact rendered application in the browser, and accordingly differences and layout issues are pointed out. We can also tag specific sections inside our spec file so that we can selectively decide and filter out the tests we want to do while executing the test. For instance, I can tag some of the attributes as desktop, or I can tag some of the attributes as with a tag of mobile, and inside my test case, inside my test script, I can provide that tag in my check to include or exclude any of the tags, and at runtime, that particular tag would be included or excluded, and accordingly a filtered out test would be performed according to the circumstance of the test. Now, as long as we are doing layout testing, this is fine. But now we are on to the next big question. How do we actually test the responsive web design using this framework? When we want to test responsive web design, we would like to check the layout of the application under various different resolutions, and that too, changing the resolution at runtime while the application is already open inside the browser. So how do we do that with our framework? Well, with the check layout function that we are calling inside our test, it takes another parameter called as resolution, which when provided to this function, the check layout function would automatically resize the browser window to that attributed resolution and perform the check accordingly. For instance, if I want to perform a test of the home page on full resolution in desktop and on iPhone resolution, one after the other, I would call the check layout function 2 times, and the first time with a different resolution value, which is desktop full, and the second time with a different resolution value, which could be the exact resolution or the name, the fluent name of that resolution, for instance, iPhone. Let me show you how this actually happens. In my test case, you can see that I have added 2 check layout methods, and the first time I'm using resolution as desktop full, and second time I'm using a specific resolution, which is 420 by 730. And when I run this test, you will see that the browser would automatically resize at that particular spot. So the browser is launched in tablet mode because that is the desired global resolution for my test. And then when the check layout function is hit, it will automatically resize it to the selected resolution, perform the layout check, and then provide the results back to the result collector, and then change the resolution back to what was the original resolution. And we have the results available. Now, besides providing the results in console and in HTML report, we can see that since this is our spec, we have an HTML report of the results available. This framework also provides a detailed HTML report of the layout tests that were performed, the failures of those tests, and image screenshots with proper annotations. For instance, in case of home page, we performed 2 tests. The first one was home page at desktop full resolution, and the second one was home page at a specific resolution of 420 pixel by 730 pixel. In both these cases, a total of 7 tests were executed. In the first case, all the tests were passed. In the second case, only 1 test failed. Let us see which test exactly failed. Now, in order to do that, I have to click this link. And this report essentially provides a detail of what test specs were executed, which specs were failed, what was the reason of the failure. For instance, we are expecting the greeting element to be near content pane element within a range of 50 to 500 pixels to the right, but it is actually minus 479 pixels to the right. So there's a difference in this specification. And we can even click on this link to see the exact screenshot of the application at this spot, and along with that, all the elements properly annotated, so that it is really easy to identify whether this is just a layout difference issue or an actual layout issue inside the application. So we don't just get the HTML execution report and pass fail, but proper annotated screenshot result as well. For instance, in this case also, we expected this element, the drop-down box to be of width at least 100 pixel and more, but it was not actually 100 pixel under this smaller resolution. Now, the next big question. One of the very important properties and capabilities that we wanted in this framework was the capability to be able to compare the layout of the application across different browsers. When you're developing the application UI as a developer, you would take one of the browsers as your benchmark browser, create the styles and the UI of the application based on that browser, and then optimize that style and layout to fit and render properly in all the other compatible environments for this application. A very similar thing we can do when we are doing layout testing. We would like to mark one of the browsers that we have tested manually properly as our benchmark browser, create our spec files, the specifications of our UI against that browser, and then compare those specs across all the different compatible browsers and figure out what are the differences between the benchmark browser and the remaining browsers. That's exactly a capability that we have available in our framework. The framework can be executed, the test scripts can be executed in two different modes. We have a benchmark run mode in which whatever configuration that you pick to execute the test in benchmark mode, rather than pointing out the issues in that mode, the test would just record the differences, annotate the spec files accordingly, and then you can go in and update the spec files, and then when you run the test against a different browser, you would essentially be comparing one browser test run against all the different browsers, and you would figure out what are the differences. Let me show you how this actually works. I would have to go back into the configuration in order to do that. There is a configuration attribute called as execution mode, which is right now set to test. I will have to change it to benchmark. So what would happen is Chrome browser would be used as a benchmark, and that too in the tablet resolution. So in the tablet resolution in Chrome browser, when we run this test, it would not give us results, but it would give us, it would annotate the spec file with the differences, with the actual values of specs inside that browser. So when I run this test, the test is executed in the tablet mode, and what the framework is doing is it is recording all the actual values from the browser, and it is putting that all those values inside the spec file. The test has failed, but if you look at the spec file, you would see that there is an annotation available in the spec file that this particular spec actually failed, and it gives us the exact actual value. Now, according to this actual value, I can modify my spec file and update it to make it a benchmark script. And then when I want to run this script in the test mode, I have to come back to the configuration, change this value to test, and change the browser name to something else so that I can compare the Chrome benchmark against some other browsers. So right now, let me pick Firefox as my browser. And when I run the test, what would happen is whatever benchmark we created in Chrome would be compared against the actual values in Firefox, and the difference between Chrome and Firefox at tablet resolution would be displayed for this web application. So this way, if we're able to compare, you can see that there are two differences, that there's register height is 20 pixel instead of 17 pixel. So there's one difference in Firefox versus Chrome, and the other difference is the greetings element is not in the proper appropriate specified range. There's another use case for this benchmark run and test run mode. Normally, the application UI is always developed in an iterative fashion. For instance, in the first iteration of the application, you might just have two features or two components available in the application UI. And when there are more features available in the application, you would add more components in the UI. You would always want to make sure that the newer components that have been added in the UI, they did not alter any of the existing component UI in the application. One way to do that is to manually check for layout issues. The other way is, in the first iteration, you create a benchmark of whatever is available in the application, and the second iteration, you run the test against that iteration 1 benchmark, and you would figure out if there are any differences in the already existing functionality in iteration 1 compared to iteration 2. So we have come to the end of this presentation, and I'd like to summarize this presentation now. This solution that we have developed, it is a totally open source solution, and it is built on absolutely open source tools. We are using Selenium, we are using Galen, and a bunch of other tools which are entirely open source, and we have bind them together with our framework and a bunch of custom functionalities using which we are able to perform functional tests as well as layout tests of web applications, and also test responsive web design inside web applications. I demonstrated today the Ruby version of this framework, but we have this framework available in not just Ruby, but also Java and all other languages like C# and Python as well. One very important aspect of this framework, and it's actually a capability which we always wanted, that with this framework, you can use your existing Selenium automation test scripts to drive the workflow in the application, and with the added advantage in the framework, you can use the same scripts to do both functional as well as layout tests. To talk about next steps, one of the very important things that we would like to do as part of the next steps in the framework to enhance this even further is to integrate one of the image comparison tools, so that we can add that additional capability of visually comparing things. And for that, we have in mind to integrate either Wraith or Phantom CSS with this framework. Although whatever we have right now already does some level of image comparison, but we'd like to expand it to the next level by adding the capabilities of Wraith and Phantom CSS. With this, I'm done with the presentation, and we are open for questions. So, open to Prashant.
Thank you, Ramandeep. This was amazing. I'm sure that this would have given new perspective and a new thought process to our audience, and this certainly does suggest a new approach to do a automated UI testing. We will wait for our audience to send their questions. I have already received a few of them. Let's give a couple of minutes, then we'll get on to question and answer session.
I think if you have questions, let's go on with them.
Right, I received a few of them, and one of them is, this one is very relevant to automated testing and whole continuous integration thing. The question is, I have a test infrastructure set up with multiple VMs on cloud. Does your solution support CI through Jenkins and remote execution? Would you like to take this one?
Well, why don't Prashant, you yourself answer this question?
Absolutely. So yeah, we have developed this solution when we were working on it on UI, automated UI testing. We came across a lot of solutions, few of them being image-based, few of them needed installation and extra installation infrastructure setup problems. So what we did, Raman and I, we made this a conscious effort to make sure that these are frameworks, let it be Ruby, let it be Java framework, they are in line with the development processes. So yes, our framework is 100% CI capable, and it does support remote execution. Not only is that, this our frameworks, Ruby and Java, use basic development tools to integrate with your source code repository. So this is absolutely hand in glove fit with your CI expectations.
Okay.
There's one more question. This is a bit technical. It says, couldn't we use Selenium get location API to achieve the same relative location mapping?
Yes, you can use the Selenium get API to get the respective attributes of any element in the web page, the rendered web page. In fact, whatever tool that we've used is actually internally using the same Selenium API. But the way we are doing this through our framework is that we now have a clear and very fluent way of describing the expected results. You know, when you want to get down into the element and its attributes, it becomes really difficult to identify what are the exact tests you want to do. But with the CSS language and the attributes that we have done, it becomes really easy for you to define the expected results and then let the tool take care of identifying the things from Selenium API and performing the test for you. So internally, the tool is also doing the same thing, but you have an advantage of doing it at workflow level and doing it more faster and easier.
There's one more question, and this one is related to how we are defining our spec files. It says, how do we exactly define the pixel-wise position of an item in the spec file? Supposedly, an item comes in left side of the browser indexed of full mode, and when the browser size is reduced, it shifts towards right, and finally in tablet view, it aligns itself below another item.
Right. So that is where that is a very interesting question, and thanks a lot for raising that question. In fact, let me take you to that specific slide in the presentation where I have the answer to this question. There it is. So we have a way to annotate our spec sections of the spec file with various tags. For instance, I can say add desktop tag. On desktop resolution, just check for these attributes in this element, and on mobile resolution, check a different attribute or a different value of an attribute for this element. I can have my spec file laid out for all these differences in the layout, and then at runtime, when I'm running the test, I can pass the correct tag to the test according to whether I'm testing inside the mobile device, whether I'm testing inside the desktop, and the tool would automatically pick the right section inside the spec file and perform the validation according to that. I just hope that answers that question. Okay, any other questions?
Yeah, that's great. Let me go through. All right, that's all we had from the participants. All right, there's one more just popped up. Where it says, where is the element locator definition written for this?
Right, that is a very interesting question. Let me show you the, do we have the screen share? Okay, let me show you the spec file. And if you look at the spec file, there are various ways in which we have done this. And we have finally come down to do this in this specific fashion. If you look at the spec file, the very top section of the spec file is where we define the element locator for each of these logical elements. So these are the greeting, sign in, all these are logical names for the elements. And this is the locator strategy. And these are the locations for these elements. So at the very top of the spec file, you define the elements, and the Selenium code would refer to these locators as well as your spec code. So there is single point at which you would define your locators, and the standard page object pattern strategy is applicable here as well.
All right, that's amazing.